A-Level Maths, Triangle Geometry. This video is designed to make sure that you are familiar with the types of problems and formulas associated with triangle geometry. In a moment you will see 10 triangle geometry problems and some formulas that could be used to solve them. Your task is first of all to match the correct formula to each diagram so that it can be solved, and then solve the problem and use good mathematical technique. When you've finished, continue to play the video to see model solutions for each problem along with a demonstration of the required mathematical technique. Here's the 10 problems along with some possible formulas that you may use at the bottom of the screen. So first, attempt to match the correct formula so that it will enable you to solve each problem, and then try to solve each problem before continuing with the video. So before we look at the solutions, here are the 10 questions again, matched up with a suitable formula which will enable each problem to be solved. So the first question requires use of the sine rule. So here's the sine rule. The top version of the sine rule, you should use that when you require the length of one of the sides on the triangle, and the second version is written slightly differently. Use that version when an angle is required. So before we solve this problem, if we just talk about when to use the sine rule. First of all, you'll know that we need to label the lengths and the angles. So length A is already labelled, and the opposite angle from that will therefore be angle A. And so if we say this is angle B, then we have side B over here, and this will be angle C, and that's side C. Now you should use the sine rule if you have an angle length pair already and you require another length or angle. So that means if, for example, you know length A and angle A, that's a length and angle pair, so you've got that, and therefore you could find another length or angle. And the same would be the case if you had length B and angle B, or length C and angle C. So if you've got a pair like that, then the sine rule is probably good to use. So in this case we have a length angle pair because we've got length B and angle B, and we're required to find length A. So we're going to need to have angle A, which we have got in this example. So therefore we can use the formula as is written there. So if we substitute the values into the formula, then we have A over sine 75 is equal to 7.2 over sine 45, and then we can rearrange that. So A is going to be the answer to 7.2 over sine 45 multiplied by sine 75. And that gives us an answer of 9.84, and that has been rounded to 3 significant figures. So moving on to question 2, this is a relatively simple example where we need to find the area of the triangle, and we can use the basic formula for the area of a triangle, which is the base times the height divided by 2. We just need to remember that the base and the height are perpendicular to one another. So if we use the base as 6.7, then we have the perpendicular height, which is 3.9. And so the area is equal to 6.7 multiplied by 3.9 over 2, and that's equal to 13.9 6.1 millimeters squared, and again that's been rounded off to 3 significant figures. Three significant figures is a standard level of accuracy that you should use for A-level maths unless otherwise stated in the question. Question 3 requires the sine rule again, and that's because we have a length angle pair. So if we label the angles, let's say this is angle A, so that makes that length A, and because we have that pair already, we know angle A and length A. So in terms of the formula, we have that pair, so the sine rule is good to use. And also, if we label the rest of the triangle, this could be angle B, meaning that this is length B, and there's angle C and length C. So we've used the other version of the sine rule here because we are looking for an angle. We're looking for angle B. And so if we substitute our values in, we've got sine 64 over 4.8 is equal to sine theta over 5. And we can rearrange that so that sine theta is equal to sine 64 over 4.8 multiplied by 5, and we can use a calculator to evaluate that, and we're getting 0.936 and so on. Now at this stage I am not going to round that off because I've still got to use that answer again in order to find theta, so I'm going to leave the answer on my calculator, and I can use my calculator then to do the inverse sine of that value, and that'll reveal angle theta. So we're doing the inverse sine of our previous answer, making sure that we don't round off that value, and we end up with 69.4 degrees. And again, that's been rounded at the end to 3 significant figures. The important thing there is that the answer was not rounded off until the very end of the question. So any intermediate calculations, such as this one here, we use the full answer that was on our calculator display. And the thing to do there is you can use your answer button on your calculator in order to make sure that you're using the full answer for sine theta before you're calculating theta. Now question 4 requires the cosine rule. So the cosine rule is written at the top. So that's here. Now you can write the cosine rule in different ways by interchanging the variables. So for example, if you take the version of the cosine rule which is at the top, which is probably the one you're most familiar with, then you could swap around the variables a and b, for example. So instead of having a squared equals b squared plus c squared, etc., you've got b squared equals a squared plus c squared, take away 2ac cos b, and you could do the same by interchanging the a's and the c's and you get the version, the third version of the formula there. Okay. Now there's two situations where you could use the cosine rule. The first situation is where if you have a triangle and you have two lengths and the angle between those two lengths, then the cosine rule is good to use. So that's exactly what we've got in this case. We've got this length, and the angle between them. And the other situation where the cosine rule is appropriate to use is when you've got all three sides of the triangle and you're trying to find an angle. In this case, we're trying to find the length. So firstly, let's label the triangle appropriately. If you look at the cosine rule that we've written down already here, then we're referring to the angle as angle A. So that's angle A, meaning that this length over here is length A. And the convention in mathematics for labelling is to label the vertices of the shape in a clockwise direction. So that makes this angle B and this one angle C, which means that this is length B and this is length C. Okay, so if we now substitute the values in, so we're looking for A squared, which on this diagram is x squared, and that's going to be equal to 15.9 squared, add 11.3 squared, take away 2 times 15.9 times 11.3 times cos 72. Now there's a few things going on in this calculation, so it's probably a good idea to work this out more than once just to check you've done it right and not made a mistake. So you could type the whole thing into your calculator in one go and get an answer for x squared. But what I'm going to do is I'm going to work out 15.9 squared add 11.3 squared. And that gives me 380.5. And then I'm going to work out 2 times 15.9 times 11.3, which is 359.34. And then in a moment I can multiply that by cos 72. And then that'll reveal, when I've finished that calculation, I'll reveal what x squared is equal to. So that gives x squared is equal to 269.457, and there's a few more decimal values there on my calculator, so I'm going to leave that because I'm going to use that again. So I'm going to work out the square root of that value to get x, and that gives me a value of x of 16.4 meters, rounded to 3 significant figures. In question 5 we need to find the area of a triangle again, and this time we're going to use the alternative formula for the area of a triangle, which is a half AB sine C. And you can use this formula for the area of a triangle when you have two lengths and the angle in between them. So that's exactly what we've got here. We have these two lengths and the angle in between. So in the formula, the two lengths are the A and the B, and the angle in between them is angle C. So therefore we can substitute those values into this formula, and the area of the triangle is going to be half multiplied by 4 multiplied by 12 multiplied by sine 77, and that is 23.4 centimeters squared, 3 significant figures. In question 6 we have a right angle triangle and we're trying to find angle x, and so because it's a right angle triangle we can use our formulas for trigonometry for right angle triangles, and we've already got the opposite side and the adjacent side. We don't know the hypotenuse, but because we've got the opposite and the adjacent we can use tan x equals opposite over adjacent. So tan x is going to be 55 over 28, and therefore x can be calculated by doing the inverse tan of 55 over 28, and that's 63.0 degrees to 3 significant figures. So question 7 is another right angle triangle. Again, we can use standard trigonometry to calculate the answer. So if we just label it first, so we've got the angle 27, that's opposite, this is the adjacent, this is the hypotenuse. Now the formula that's written down here is a little bit confusing because they've used x for the angle, so I'm going to just change that to sine theta equals opposite over hypotenuse. So in this case we have sine 27 is equal to 12 over x, and if we rearrange that, x will be equal to 12 over sine 27, which is 26.4 centimetres, and again that's three significant figures. Another trigonometry question for question 8. Again, I'm just going to change that to cos theta equals adjacent over hypotenuse. And then we've got, if we just label our triangle, that's the opposite side, there's the hypotenuse, that's the adjacent. So if we substitute in the values, we've got cos 23 is equal to x over 36, and rearranging this one gives us x equals 36 multiplied by cos 23, and that's 33.1 centimetres, three significant figures. Question 9 is a right angle triangle, and we can use Pythagoras' theorem to calculate the length of side labelled x. So if we label the sides A, B and C, so we can substitute them into the given formula. In this case that becomes 12 squared plus x squared equals 14.5 squared, or x squared equals 14.5 squared subtract 12 squared. So we can calculate our answer by doing the square root of 14.5 squared subtract 12 squared, and that's 8.14 centimetres. The final question is an example of when you would use the cosine rule to find an angle, and this would be when you've got a triangle and you know all three lengths and you are wanting to find one of the angles. And here we've used a rearranged version of the cosine rule. So if we take the standard version of the cosine rule, which you'll be familiar with at the top of the page, that can be rearranged into 2bc cos A is equal to b squared plus c squared subtract a squared, and then if we divide by 2bc, we get cos A equals b squared plus c squared subtract a squared divided by 2bc. So that's the version of the formula we're going to use here because we're looking to find an angle. So labelling the lengths, the angles have already been labelled A, B and C, so the lengths are, that's got to be length A because it's opposite angle A, length B is opposite angle B, and length C is opposite angle C. So we can now substitute our values into the rearranged version of the cosine rule, and so cos x is equal to 5 squared add 3 squared subtract 5.5 squared all over 2 multiplied by 5 multiplied by 3. So that's 3.75 for the numerator and 30 for the denominator. So cos x is 3.75 over 30. And so x is going to be the inverse cos of 3.75 over 30, and that is 82.8 degrees to three significant figures. So just to summarise, for A-level maths you're expected to know and be able to use the trig identities for sine, cosine and tangent in right angle triangles, and also you need to be able to apply the sine rule and cosine rule formulas when we've got a non-right angle triangle, and also use the formula for the area of a triangle, that's a half AB sine C. Now you'll also be expected to use radian measure for angles. At the moment you'll be familiar with using degrees for angles, and you'll learn about radians when you are in your first term at college. So to follow on from that summary, here's 5 more examples of problems to do with triangle geometry. Each one of these uses either the sine rule, the cosine rule, or the formula for the area of a triangle, and it shows the level of detail that you're expected to show when you are performing these calculations. Now we're going to complete this video with a really important example, and this is called the ambiguous case of the sine rule. And this occurs when there is more than one possible answer for a problem that requires the sine rule. Now the word ambiguous means not entirely clear, and in this case we have some information about a triangle and it's not entirely clear how this triangle should look, and in fact there are 2 possible ways that this triangle could look, and therefore it is ambiguous. Now if we attempt to draw a diagram, we know for definite that A to B is 11 centimetres and angle B is 25 degrees. What we don't know is how long the length from B to C is. So I've extended the line from B indefinitely because we're not quite sure where that line will end. Now A to C is 7 centimetres, so it could look like this. It could be that point C is here, where this is 7 centimetres. However, it could also be that C is here and this is 7 centimetres, and that's because this length and this length are both the same, but it could be in 2 different positions, and therefore we've got the ambiguity generated from the fact that with the information in the question doesn't make it exactly clear whether angle C is going to be this angle, which would be an acute angle, or whether or not it's going to be this angle, which would be an obtuse angle. So if we go ahead and label the rest of the triangle, we've got the 3 angles A, B and C labelled, and so this is going to be length C because it's opposite angle C. The 7, whether it be this one or this one, is going to be length B, and therefore the other length between B and C is going to be length A. So in this question we've got a length angle pair. We know angle B and length B, and we're trying to find angle C and we know length C. So we can use the sine rule. So if we set that up, it's going to be sine C over C is equal to sine B over B, and if we attempt to do the calculation, then we're going to get sine C over 11 is equal to sine 25 over 7. So if we rearrange, sine C is equal to sine 25 over 7 multiplied by 11. So we get sine C is equal to 0.664, and then there's some more digits on the calculator display. So we can calculate angle C by doing the inverse sine of that answer. And the answer that appears on your calculator is that angle C is 41.6 degrees. That's the 3 significant figures. So if we refer back to the diagram, 41.6 degrees is an acute angle, So that's clearly telling us what this angle here is. However, because we know that this is the ambiguous case of the sine rule and there are two possible answers from the diagram, we need to calculate the other possible answer, and we can use the fact that part of the diagram there is an isosceles triangle, and we've just calculated that this angle here is 41.6, and therefore this angle must be 41.6, and therefore the other possible angle for C must be 180 subtract 41.6, and so the other possible answer is that C is, remember that 41.6 has been rounded off, so I'm going to use the full answer to get 138.4, so that's 138.4 degrees. So we've got two possible answers for angle C in this case. So to summarise most of the things that we've looked at in this video, we have the sine rule, two versions of the sine rule. The first one, use that when you require an angle. The second one, when you require a length. And you should use the sine rule when you've got an angle length pair as part of the question. And look out for the ambiguous case, as we've just seen in a previous example. We also have the cosine rule, and we can write that in different ways, as we've seen, and we might need to use the rearranged form if we are looking for an angle. And you should use that when you've got two sides and the angle between them. So here that's described as two sides with the included angle, or if you've got all three sides of a triangle and you require one of the angles. And finally, you've got the formula there for the area of a triangle, a half AB sine C. And angle C there is the included angle, or the angle between sides A and B.